All right, so let's get started. Thank you for joining me after the lunch. So in the next around 40 minutes, we will dive a little bit into how you can use structured concurrency and scoped values so that you can use the virtual threads to their highest potential. So, short introduction to myself. My name is Christian. I've been working as a software engineer for the last 15 years now. Started back with Java and the original Spring, then switched over to more of a full stack role like 8 years ago when Angular 2 was released. So since then I'm working as a full stack engineer, front end with Angular, JavaScript, TypeScript, and in the back end still with Java and the whole Spring ecosystem. I also was recently announced Microsoft MVP for web and developer tools, so I also do quite some stuff in the UI part, especially in TypeScript. I also do some trainings on the side or do code reviews for companies. And also I really enjoy, of course, doing conference talks like this one. And I also recently, like half a year, I started doing some content on YouTube about advanced stuff in TypeScript. If you want to get in touch with me, just visit my website, type.rocks. There you find my LinkedIn, GitHub, and my YouTube. So if you have any questions, just send me a message on LinkedIn. So if you have questions, you can ask them all the time. You can go to type.rocks/QA. You can then enter your question there, and then we have enough time at the end of the talk, then I will answer them right away. But if you don't have enough time, just come back later, and you can see your questions answered. So what are the topics we will talk about today? We will have a short introduction about virtual threads first. Short show of hands, who has worked with virtual threads? Who knows what they are? Okay, then it's nice that I will do a short introduction for that. The second thing, then we will talk about StructuredTaskScope and the structured concurrency model. And we will also see how you can use ScopedValues instead of ThreadLocals if you are using virtual threads. And at the end, we will just make a short recap. So let's get started with a short introduction to what virtual threads are. If you're interested in a more in-depth explanation what they are, just go to typerocks/VT. This will link you to a YouTube video I've done on a conference talk in NDC Copenhagen, which will then show you exactly how virtual threads work in detail. So why were virtual threads introduced? Virtual threads went live in Java 21, and the issue we had before was when we created a thread in Java, this was quite expensive. So this means that when we created a thread in Java, it created a thread in the operating system, and this takes around 1 to 2 megabytes of memory per thread. This is why we have such things as thread pools, because the creation of a thread is expensive and it takes much memory. And this is also why we can't just create like hundreds of thousands of threads, because you don't have enough memory on your system to do that. And this is why we switched over to reactive programming, because then we could work with much less threads, but you still have this huge throughput in your system. But the issue with the reactive programming is that you have quite some boilerplate around your code. Like you have to keep everything asynchronous, so it's quite hard to do this and to understand this because it's quite a different paradigm than normal sequential coding. And this is why virtual threads were introduced in Java 21. They worked for this over 5 years, and on a simple term, what a virtual thread is, it's exactly the same as a normal thread. But when you create the virtual thread, then it will not create an operating system thread. This only lives in the JDK. So what this does is, this helps you to make it much cheaper. It's only like 1 to 2 kilobytes, so it's like 1,000 times cheaper than a normal thread. But these virtual threads work on normal threads. So let me show you how this works. Let's say you have an endpoint, like you have a REST application, and then somebody calls your REST application. What happens is, for example, when you're using this with Spring Boot, this creates a new virtual thread. And this virtual thread is really clever because it looks in a pool of worker threads for a thread which is available to do the work on. So this virtual thread, which is just living in Java, searches in this pool of worker threads which have an equivalent on the operating system. If one is available, it connects itself to this worker thread and starts doing the work. For example, serializing a request. But as soon, and this is the clever part, as soon as something blocks, for example, as soon as you have some I/O, or for example, if you're calling an endpoint in your code, then the thread blocks and the virtual thread understands that and removes itself from the worker. So this means the worker is now available for all the other virtual threads which are there. And this means we can work with extremely low amounts of worker threads. For example, to have like for a normal application, normal REST application, you need around 40 worker threads to handle like 1 million virtual threads. Because the most amount of time a virtual thread uses, or a thread at all, uses is waiting for some I/O. Now, as soon as the result comes back, as soon as the virtual thread understands, now I have some data I can work with, it looks for another available worker thread. So you maybe have spotted it. It's not the same worker thread as before. It doesn't have to be. It can be any worker thread available, because this is just like he needs somebody who he can work with to do the work. But for you as a developer, a virtual thread is exactly the same as a normal thread. You don't see any difference. Now, let me show you how they work in code. So we are here in IntelliJ. We have an empty application, empty Spring Boot application. I'm using here Spring Boot 3.3 with Java 23, but of course you can also do this with Java 21 and Spring Boot 3.2, because you have to enable some preview features so that you can use StructuredTaskScopes, but virtual threads are available since Java 21. So what we will do here is we will create a new Java class, and we'll say we create a main controller. Now, this main controller will be a REST controller, and we say we have a request mapping of API. And what we'll do in here is we will create a really simple web application. So we say we have a get mapping here, and we say we want to access the talk for a speaker of this conference. So we say we return a talk here, and we say get talk, and then we have our path variable here, and we have our parameter we pass in here. Now, this talk here is a really simple object. It's just a record we have, and this will just contain a name here. So what we now could do, of course, is we could use a real REST template, so to call some endpoint. But we want to make this like as reproducible as possible, so we will create like a fake REST template. So what we do is we have here our auto-wired, and we have our private fake REST template. And this fake REST template will just be a service we will create. So let's create this class here, and we just say service. Now, what we will do in here is we will just call our fake REST endpoint. So we say return fake REST template, retrieve talk, and we pass the speaker. So what this retrieve talk here is doing is it just returns to us a normal talk object. So we say return new talk, and we say talk for speaker, and then we have here our speaker. Now, of course, we could leave it like this, but this would be way too fast because we want to fake a REST template call. So what we need to do is we need to say we have a thread sleep here, for example, of 1 second, because this is exactly what happens when you are calling a synchronous REST client. Of course, you don't have this thread sleep, but what happens is the thread gets blocked until the result comes back. So let's add here a try catch around this. And now we are already ready to start our application. And we can now test our performance. So I will switch here to JMeter. JMeter is a simple application to test the performance of your endpoints. So what I will do is I will send a request with 1,000 concurrent users, and it will just access this endpoint. Now, let me get this started. So let's run this. And what we will see is that the responses will get slower over time because our thread pool of 200 threads is not big enough to handle all these 1,000 requests which come in at the same time. So the response will get slower over time. So we will see this right after 20 seconds. We have our results. So let me show you in the response time graph how this looks like. So let's show here display graph. And we can see here it started at 2 seconds because we started to record after a ramp-up time of 10 seconds. And it goes until almost 5 seconds, 4 seconds, 800 milliseconds. And this is because we have this thread sleep and this thread pool of 200 threads. Now we can fix this, and we just open our application properties, and we say Spring Threads Virtual enabled true. Now what this does is it just enables the virtual thread executor in Spring Boot. So instead of using Tomcat instead of using the thread pool of Tomcat, we have another executor service which creates a new virtual thread for each of the tasks, for each of the requests which come in. So let's restart this. So I didn't change anything in the code, just enabled this property. And let me now just clear this and rerun the test. Now, what now happens is the request comes in, a virtual thread gets created. The virtual thread looks for one of these worker threads which is available, connects itself to it. As soon as it sees this thread sleep, it disconnects itself from the worker thread because it knows it doesn't have anything to do now. And as soon as this thread sleep is done, it will then come back, look for another worker thread, and return the result. So we can now see the graph here, and we can see it now takes 1 second. And this is only by enabling this one property in Spring Boot. Of course, you can also use this outside of Spring Boot. When you have, for example, an executor service, you can use this special executor service by using executor's new virtual thread per task executor, and this does exactly the same thing. Now, this looks nice, but we still had an issue when we only had virtual threads. Because when you have a more complex call structure in your code, then the virtual threads are just not enough to help you. So why is this? Let me show you this in code. So let's go back into our main controller. Now let's say we don't want to just return a talk. We want to have some additional information from our speakers, and we also want to return this. So let me show you what I mean. Let's say we have a get mapping. We say /speaker. And then we have our speaker in there, and we want to return information about a speaker. So we say we have our speaker with the path variable, and we have our speaker in there. Now, what does this speaker here return? This speaker is a simple record, and this speaker contains the talk information, but it also contains some information about the speaker itself. And of course, this infos object is just a normal record. So we say here, this is an infos record, and we say this contains a list of strings, and we have our information here. Now, when we say here, we want to create this speaker. When we would do this asynchronously, this would of course look different, but when we would do this sequentially, like normal blocking behavior, then we would say final var talk, and we say fake rest template, retrieve talk, and then we get the talk from the speaker. And now what we will do is, we try to gather some information from different info sources. So we say final var infos Google, for example, and we say here fake rest template, retrieve Google, and we pass in our speaker. Now, what does this retrieve Google do? This is also, of course, now a fake rest call. So we say we have our infos here, which we return, and we just say return new infos with a list of information here, and we have our speaker in there, and for example, it knows my birth date. Now, what we do additionally is we also have a thread sleep in there. Let's make this 500 milliseconds. And now what we do is we also add this for LinkedIn and, for example, for Facebook. So I will copy this, and I will say retrieve LinkedIn, and we say here this has a little bit more information about me. And we do this a third time for Facebook. But for Facebook, we have something different because I don't have a Facebook account. So we will throw an error as soon as we try to access this. So we say throw new illegal state exception, no data found. Now, when we try to use this in our main controller here, let's copy this. And when we try to use this, we can just say, for example, LinkedIn. And we also say here, instead of Google, we say we have Facebook. Now, when we try to do this, we of course need to gather all the information from these three sources, and we want to have the best information. And best information in our case is just the one with the most information. So we say we have our final var best infos here, and we say stream of infos Google, infos LinkedIn, and infos Facebook. And then we use a max to figure out which of the lists is the largest. So we say infos.information.size. And then we say or else throw. If there's nothing found, then we throw an error. So now we just return this. We say we have a new speaker with the talk and best infos. Now, what's the issue we currently have with this code? This code is, in my opinion, perfectly readable, but it's quite slow, because this one here takes 1 second, and this here takes 3 times 500 milliseconds if there is even a response. Because Facebook here will throw an error, so our whole request will fail, and we will get an error on the client side. Now, this means everything here together takes 2.5 seconds. And this is why virtual threads are just not enough, because when we have such a complex construct, it isn't enough that we just don't have this delay of the initial call, but we want to do this concurrently here. So, and now some people maybe are asking, yeah, well, you now can use reactive inside of this virtual thread to make this faster. You can do this, but this is exactly what we don't want to do, because virtual threads were developed so that we don't have to use this reactive stuff. Because this would look something like this. This is like how you would do it when you would use asynchronous programming. And it's not like, I'm not exaggerating it here, I'm even like putting some stuff not even in there. For example, this error wrapped function is not in here, but this takes care of what happens when an error appears, then it maps it to an empty list, and so on. Now, what you also don't see in here is you would have to rewrite all your functions, all your methods to asynchronous, because you're not allowed to have any synchronous call in your asynchronous chain, because then you will have blocking, the blocking errors which you still have with synchronous. And you can see the only real code of the business logic is on this line with max here. And everything else is like wrapped around so that we have these asynchronous calls. And this is something I think which is not really that nice, because somebody tried to solve an issue with reactive programming, but now he has 2 issues. Because maybe you can solve it, but it's quite hard to read. You also always have to think about what is the maintainability of such code. So let me now show you how we can solve this using structured concurrency. So let me show you this with a so-called StructuredTaskScope. So let me go back into our code here. Now, what is a structured task scope? It's really simply said, a structured task scope is nothing else than an executor service, which for each task you give to him, it creates a new virtual thread. So what we can do here is, first let's remove this here. And what we now can say is we have our try with resources block, we say var scope, and we say this is a new structured task scope. Now, as you can see, this is a generic class, so we now can say which kind of tasks we want to use this scope for. So we say we want to do this for infos, and now we can wrap everything around this, and we are done. No, of course not. This would be a little bit too easy, but what we can do is we can use scope.fork, and with fork we create a new virtual thread. So we say we want to run here our retrieve Google with this scope fork. Now, what is scope fork returning? You can see here we get back a subtask. So with the scope fork, this starts this subtask in its own virtual thread. And the subtask is quite cool because this subtask has 3 different states. The first state is unavailable. This means it's still running, so you don't have any result. Second one is success. This means it was successfully finished and you can access the result. Or failed, there was an error inside of this task and you can access the exception. So this means that you don't have to handle the exception right where it appears, but you can handle it after everything is done. So let me now show you how we can do this also for the other ones. So we will also wrap everything else here around in scope fork. Now, we tell this structured task scope, start these 3 virtual threads. Then we tell, listen scope.join with scope join, we are telling Java, wait for all these tasks we've given to you to finish. And don't go further until they are done. So we do this here with scope join. And we say we throw an exception in case where something unexpected happens. Now, what we of course need to do in here is we now have a stream of subtasks. Now, of course, what we now have to do is we have to filter to only get the subtasks which were successful. So we say here filter, and we have our task, and we say task.state equals state success. So with this approach, we have the advantage that we are only having to deal with the successful tasks on the next line. So we now say map and we say subtask.get, because now we are sure that we only have the successful ones and we can get the result from it. So let me now restart the application. And let's now see the speed difference we have here. So what I now will do is I will switch over to this other API endpoint, and let's just rerun this. Now what will happen here is we will enter here with a virtual thread. This one virtual thread handles this retrieve talk. Then when it's done, this virtual thread starts 3 other virtual threads, waits for the result to finish, and then gathers the information and returns it. And it's important, these ones are still synchronous. We did not change this. It's still like a synchronous function. We only wrap this in so that it's called in a virtual thread. So let's go back into JMeter and see the result. And we can see here this takes 1.5 seconds. So we did these 3 info calls concurrently, and we did this retrieve talk before, so it takes now 1.5 seconds. Now, of course, when we go back here in our code, this now looks a little bit cluttered. So what we can do is we can just move this in our own function. So we say here we have a new function which returns infos, and we say get infos here, which takes a speaker. And we say here we have this as before. Now we just throw this here, and we now can just return this result. Now, of course, the speaker we don't need here. Now we can go in here, remove all that, and we just say we have our final war infos, and we have this get infos call here with our speaker, and we have this infos here. Now, I just moved it a little bit outside so that we can now look at the get infos a little bit more specific. Now, this get infos here, we can see here we have quite some code here with the structured task scope. We are doing some stuff here, and while it's still readable, it does not really have the business logic at its own. So we can fix this because we can create our own structured task scope. So how can we do this? First, when you need a certain kind of structured task scope, there are 2 from Java themselves: shutdown on failure or shutdown on success. This means shutdown on failure stops immediately when the first failure appears. Shutdown on success stops immediately when the first successful one happened. Shutdown on success is, for example, helpful if you call like 3 different endpoints, but you only want the first one, you want the fastest one, then you use this one. But in our case, this is not the case. We don't want the fastest one, but we want to have the best one here. So because of that, we need to create a new Java class, and we need to create our own task scope. So let's call this info task scope, and we say extends structured task scope of type infos. Now, the cool thing about structured task scopes are that the API is really cleverly implemented because we can just override this handle complete function. This handle complete function gets called every time a subtask has ended, so either successfully or failed, doesn't matter. And now in here, we can gather all the information and do our business logic. So we can say, for example, we have our private final collection of our infos here. And we say we have our results in here. And I use a concurrent linked queue. Why do I not use an array list? Because array lists are not thread safe, and this gets accessed by different threads. So we need to make sure this is a thread safe implementation. Now, in here, we can say if subtask state equals state success. In this case, we call results.add, and we can call subtask.get, because we know a successful task has a get method we can call. Now, what we also can do is we can say we have a list of throwables, which we call throwables here, and we say else if subtask.state equals subtask state failed. In this case, we add it to the throwables by saying .add, and we say subtask.exception. And this is something I need to emphasize, is that the cool thing about the subtask is you can handle the errors when you are done with everything, and you know now I'm ready to check if I need to handle the exception or not. For example, if you're accessing 10 endpoints, but you only need like information from 3 of them, you will not handle the errors until you don't have these 3 results you wanted. So now what we can do here is we create a function, we say best infos, and we can just say return results stream maximum here, and we do the comparing again. We say we have our info.information.size, or else throw in our case. Now, of course, in here you could check, are there any results? If not, throw the throwables, but we will keep this simple in this case. So let's now go back into our main controller, and now let's use this info task scope here. The first thing is we can remove this existing one because we have our info task scope. The next thing is everything in here we can remove. We can just call scope best infos, and we also don't need this assignment here because we don't call the subtasks themselves. They are handled in the info task scope. And this is now everything we need to do to have our own info task scope. And when we go in here, this is quite easy testable. You just create a new, in your JUnit test, you create a new info task scope, you just send some requests to it by using scope fork, and you then check the result. You don't have to have like a framework or a library which makes these asynchronous calls synchronous again. You can just use it like you would test normal synchronous code. Now, but let's now go back into our main controller. Now, this is now looking fine, but what you also want to have is retrieve talk should get called at the same time as get infos, because these 2 requests are not dependent on each other. So we can make this even faster. So how can we do this? Well, we just wrap this again in another scope, and we say this is a structured task scope. And now what we can do is we wrap it like this, and we say to the scope we want to use a known virtual thread for this first call, and we also want to have a scope fork for this second call. Now what we of course need to do is we need to say scope.join because we want to wait until the infos and the talk is done. And now we can say talk.get and infos.get. Now of course here you could also check were they both successful or the states failed, but we will keep this simple now in this example. Now you maybe have seen I did not add a class in there. Now, this is okay, but the issue is I could currently do this. I could say I just pass in any callable I like because object takes anything. And to fix this, we can use an interface. So we can say we have a speaker info interface, and this will be some special kind of interface. This is a sealed interface. Sealed interfaces are available since some time, but the cool thing about sealed interfaces, for the ones of you who have not used it, is that you can restrict which classes are allowed to implement this. So we can say permits, talk, and only talk needs to implement this and is allowed. And we can also say infos needs to implement this and is also allowed to do this. Now, every other class is not allowed to implement this interface. This is helpful, for example, when you have switch cases where you want to check, where you, for example, say case talk and case infos, then you don't need a default case when you have the sealed interface because the JDK knows there is no other class which could go into this default case. Now, as you can see now, we are now done with everything works still as expected, but now when I say here instead scope.fork, and I pass something else, we can see now we get an error, of course, because the interface is not implemented by this true. Now, let me restart the application. Let's see our final test. So let's go into JMeter here, clear everything, and let's rerun this. Now, what happens here? We get a request from our speaker endpoint. The first virtual thread gets created. This virtual thread then creates a scope, and the scope here creates another virtual thread for this retrieve talk and another virtual thread for this get infos. This retrieve talk here is just doing its thing, but this get infos here just creates another scope and creates 3 more virtual threads. They then wait for the response until everything is done and return the best infos. Then also, when everything is done, when these 2 virtual threads are done with scope join, we get back the result from both. So we now can see we are already done. Let me show you the graph, and we can see this now takes 1 second. because the retrieve talk is the thing which takes 1 second, so there is no way that we get a faster result. But as you can see, still the error which gets thrown from retrieve Facebook does not affect us because we're just ignoring it. So short recap about the structured task scopes. We have 4 really important things, in my opinion. First, it's really easy to create them. You make a structured task scope, use scope fork, and you have your subtask. You then use scope join to wait for the result and handle it. Also, it's really easy to manage them. You have effortless error handling because you just check the state at the end. You don't have to catch different kind of, okay, there was now a 400 bad request or something else. You can just handle it after it's done. Third one, it's really easy extendable. This means you can just create your own task scope and handle your business logic in there. And in my opinion, it's really easy and readable code. You don't have this boilerplate stuff with asynchronous code around. You just can write your synchronous code and can then just wrap it inside of these structured task scopes. Now, but some issues which now occur when you're using virtual threads with structured task scopes are that ThreadLocals don't work maybe as you would expect them when you have a thread per request model. So let me show you what I mean with this. Let's go into IntelliJ, and let's say we want to extract the header from each of our requests, the user header, and want to make this available for all for the thread using a ThreadLocal. So let's create a new Java class here, and we call this user filter. Now, this user filter is a component, of course, and we say this implements filter. Now, this is a Jakarta servlet filter, and we say we want to implement this doFilter method. Now, the first thing we do is we extract the user header from our request. So we say we have our final var user header, and we say this is an HTTP servlet request, and we say we have our header user here. Now, how do we set a thread local? Well, we just create here a new public static final thread local of type string, and we have our user thread local. And what we now do is we just go in there and we say user thread local.set, and we set our user header. Now let's call the filter chain so that we can just pass this forward. And now we have added our user header to our current thread, to the user thread local. Now what happens, but let me now show you what the issue with this is. Let me go into the main controller, and we say here system out, and we say main controller thread local, and we access the user filter user thread local.get. And let's just copy this and do the same here in retrieve talk. So we go in there and we say retrieve talk thread local. Now when we restart this, what we now will do is we will do a call to our API endpoint with the user header set to test. So let me run this. And now what we can see is that the main controller thread local here has the value test, but the retrieve talk thread local has the value null. Why is this the case? Well, because thread local, as the name implies, is only available in the current thread. But when we check here in our main controller, this retrieve talk here is done in its own thread. So this means because thread locals by default are not inherited to child threads which are spawned from the parent, this will not get access to it. So you would have to use like an inherited thread local, but this is like the normal behavior means that you don't have access to your thread locals, of course, in your newly spawned virtual threads. So how can we fix this? Well, this is exactly why we would use scoped values. Scoped values are done like this. You can just say this is a scoped value. We say this is a user scoped value. And we say here, instead of new thread local, we say scoped value, new instance. And now, how can we set this value? Let's try this like this. But you can see there is no set on the user scoped value, on our scoped value, because scoped values are read-only. You have to set them in a scope. So what we do is, we just say scoped value, and we say run where, And then we say the key is our scoped value, the one we created here, and the value is our user header. Now, as you can see, we need a third argument. The third argument is a function call, is a callable, which we have to pass the context where this scoped value is available. So we can put our filter chain in there. Let's surround this with try catch here. And now what happens is we tell Java, listen, we have this user scoped value, set the value of it to this user header, and make it available in this context, in this scope. Now, because we have our user filter active, everything which comes after this is inside the scope of this scoped value here. So what we now can do to check this, we can go into our main controller. Let's just copy this, and we say scoped value. We use user scoped value.get, and the same we also do here for retrieve talk with our scoped value, user scoped value. Now, let me restart the application. And let's just open our generate requests again. Let's run this. And what you will see is that everything is still the same, but we now have access to our retrieve talk, to our scoped value in our retrieve talk. Because scoped values are not restricted to being used in only a thread, but in a context, like you can set your own scope. And this is also helpful, for example, if you don't want a whole thread to have access to something, but you can say, I only want a part of a thread to have access to a certain information without having to pass it in as an argument. So to see the difference again about ThreadLocals and ScopedValues, first one is ThreadLocals are per thread. So this means you set it once and you have access everywhere in this current thread to this value you've set. ScopedValues, on the other hand, are set to a variable scope, to a scope you define yourself. Next one is ThreadLocals are mutable. I can just update the ThreadLocal variable anywhere in my code by using .set, but ScopedValue, you can't do this. ScopedValues are read-only. Of course, you can, inside of your scope, you can set a new scope and update it there, but in the main scope, you can only set it once. Also, ThreadLocals are by default not inherited, so there is no inheritance in child threads, but ScopedValues, on the other hand, are inherited in child scopes. As we have seen here with the retrieve talk, the value is still available. Now, you maybe are asking, well, when should I migrate to the scoped values when I have, for example, something with ThreadLocal? I would highly suggest that you do an upgrade or do migrate when you are using virtual threads with structured task scopes, because then it's really likely that you will have some bugs because the ThreadLocals will just not be available in the other virtual threads which get created. Also, a really cool tool I can really suggest you using is this JDK trace virtual thread locals, because when you enable this, then you will see if you call or set a thread local variable in a virtual thread. So you can then clearly see in a stack trace, okay, there is still something missing. Also, when you need a specific context, you don't want it to be available in the whole thread, but if you want to only be available in a certain part of your application, also I would suggest you to migrate to scoped values. And if you need to make sure I can only set this scoped value once and can never override it somewhere else in the application, then I would also use it like that. So, short recap. We talked about virtual threads. With a brief introduction, we saw how we can use them and how they work in favor of using platform threads, how much faster they are. We also saw how we can leverage the structured task scopes and structured concurrency to make our code much better readable than using reactive, but also making it run code concurrently. And we then also saw how we can use scoped values so that we don't have to rely on thread locals, which only are restricted to like one thread local, to like the current thread. Another recap. Now, let's go to, we have 5 minutes left, I think. So let's go to the questions. So let's switch over there. And I don't think there were any questions. So either everything is completely clear or it was a little bit too fast to ask questions. But of course, if you now have any questions, just raise your hand. Yeah, maybe back there.
Hi, thank you. Just a question. In the case of handling the user from the header, right?
Yeah.
Why not use a request scoped object that guarantees us that we have just that value when the request is created, it's available everywhere?
Yeah, of course. This was just like of course you could absolutely do that to use like a request scoped object. Of course you could do that. I just wanted to show you like that it's like available from the start on. But of course you are completely. This is not like this real use case. You would really have to use it like this. You could, especially in Spring Boot, you could of course use this. But maybe if you have your own framework or something like built yourself, maybe you don't have this kind of tooling, so I wanted to show you. But you're absolutely true. Yeah.
And if I can ask in your opinion, there is a difference in terms of efficiency with this approach compared maybe with a request scope, in which in the end we will have a new object, a new request scoped object every time that a new HTTP request arrives, right? Mm-hmm. So in your opinion, you expect differences in terms of performances or not? Because if understood correctly, with the scoped value, we have just one. It's a kind of map, yeah, and the object is there.
Yeah, it's like, I can't really say you the difference between the request scoped object and the one from the scoped value. That I can't really tell you because I did not measure anything, but I can tell you that the difference between ThreadLocals and scoped values are huge, because ThreadLocals were used for thread pools, but when we now create millions of virtual threads, then ThreadLocals are much slower than when you use scoped values. But I don't really know the difference of request scoped than the scoped value.
Thank you.
Thank you.
Hi.
Hi.
We see just as variable scope are working with virtual threads, but are they also working with the plain old thread?
Yes, absolutely. It's just like in your, maybe I can show you right away, when we are here in like, let's say, make controller, you can say here, virtual, oh, sorry, you mean that this structured task scope work with normal threads, you mean? No, they are using the virtual threads under hood. I don't think it would work with this. Also, it's, I have to say, I did not really try this, but I don't think that, I think you have to have virtual threads enabled so that this will work. Okay. But I'm not 100% sure. I did not try this.
Thank you.
Are there any other questions, or all else just ask me later or on LinkedIn? Yeah, here.
Hi, thank you for the talk. Do scoped values work with conventional threads, or do they not work?
Yeah, they work. It's like it's just that that it's not set to one thread, but in this scope it doesn't matter. Every thread has access to this scoped value in there.
Yeah, regardless of whether it's an OS thread or
yeah, exactly. Doesn't matter.
Thank you.
Yeah, if there is nothing right now, as mentioned, just write me a message on LinkedIn if you have any question. Yeah. Thank you very much, and have an awesome conference. Thank you.